So the sponsor we'd like to highlight as part of this session is Google Cloud. This is a talk about finding vulnerabilities in AWS. But the sponsor we're highlighting is Google Cloud. The lunch, which is right after this, has been also generously sponsored by the AWS VDP team. I believe they're here in the room. Please say hi to them and say thank you. Don't forget to visit the great sponsors. This talk is about how AWS can change your security posture without telling you and not through breaches. So our next speaker discovered this firsthand when he discovered the ALBeast vulnerability. This led him to create AWSSecurityChanges.com. So it's my pleasure to introduce Liad, who's the head of research at Migo Security with 8 years of vulnerability research. So please give him a warm round of applause to welcome him. He's about to show you how docs might change your security posture, and you might not even know it.
Okay, so hello everyone. I'm very excited to be here today. And yeah, my name is Liad Eliyahu. I'm the head of research at Migo Security. And today I'm going to present to you the AWS Security Changes project and how we uncover hidden changes, hidden security changes in the AWS documentation. So let's start. We're going to talk about what is even the ALBeast, the vulnerability that started it all. We're going to talk about the disclosure process to AWS and the reaction. And then we're going to talk about different variants of the ALBeast vulnerability that we found in the documentation. Later, we're going to talk about the project itself, how it operates and works. And ultimately, we're going to talk about a specific flaw that we found using the project in AWS. So a little over a year ago, under unexpected circumstances, we found a vulnerability in the ALB service, the application load balancer service in AWS, that allowed us to bypass authentication to thousands of organizations worldwide, including Fortune 500 companies and governmental organizations. To date, ALBeast has resulted with 4 distinct CVEs, 2 at AWS's own libraries, 1 at HashiCorp, and 1 at the GCHQ, which is the UK's intelligence agency. The vulnerability had a lot of impact over a lot of projects and systems. Some of them are open source and some of them aren't, and projects with thousands of GitHub stars and forks. Okay, so before we talk about the vulnerability itself, let's talk about this specific feature, this specific vulnerable feature. So ALB offers an authentication feature to the customer, which means basically that customers can offload the authentication process and enforce it at the ALB level instead of enforcing and implementing it fully at the application level and code. So basically how it works is that you choose your own IDP, and whenever a user sends a request, you can choose one of the known IDPs, Okta, Google, Microsoft, and so on. And in our case, we're going to stick with Google. And then the ALB will redirect you, will show you basically a sign-in page that once you press the sign-in button, will redirect you to an authentication with your IDP. After this authentication is completed, the ALB exchanges the authentication code and gets an ID token and access token in exchange. And to mark the user as authenticated user for the current session, the ALB will set an encrypted cookie for the user, so it will stay logged in. And once the user sends again another request presenting the encrypted cookie, the ALB now signs a new token, the ALB token, that contains some fields. We're going to talk about them in a second, but basically, this is a new token that the ALB itself signs. Now, the application needs to validate this ALB token, and we're going to talk about how it should do it. So the new token now contains 3 different fields that we should pay attention to. The first one is the issuer field, which is usually the IDP that originally signed the token. And it's part of the OpenID standard. The second field is the email, but it could be any other identifiable field and users' permissions and claims. And the sub field is the main field that you should identify the user by in OAuth. And the last one is the signer field, which is a new field that AWS added to the protocol, and it mentions what is the ARN of the ALB that signed the token. And with this gun set on the table on the first act, let's continue with the plot. So during an onboarding of a new client, we had to support their way of authentication, which you may guess at this point was the ALB authentication integration. And looking at the telemetry, we noticed an egress request to the public key server URL, as you can see on the screen. And looking at it carefully, it seemed that this domain seemed to be shared for all the tenants in the region. And this caused us to raise an eyebrow. So to better understand the rationale behind it, we went straight to the source, which is, of course, the AWS documentation. But when we read the documentation, we discovered that indeed there's a reason for concern. We discovered that the public key server is indeed shared for all the tenants in the region, which means every instance can sign a token that could be validated by any other instance. And when we say instance, we mean application. And this is a part of the AWS documentation that instructs users and customers how to assemble the public key server URL and where to pull the public keys from to validate the token. So we already walked through how ALB authentication works. And to better understand the security issue, let's take a deep dive into how tokens are actually being signed in the region. So AWS invented a new field for the JWT token, for the ALB, that is called the signer field. The purpose of the signer field is to mention what is the ARN, the Amazon resource name, of the ALB that actually signed the token for the application. And it's important to know that this field isn't part of the OpenID standard, so AWS extended the protocol, but they did it without documenting it. This is highly deviates from OAuth 2 best practices. So as you can see, when the user authenticates against the ALB takes a private key and signs the token with it, and then stores the matching public key in the regional key server. The new token now contains two fields that need to be validated: the well-known issuer field of the OpenID standard and the signer field that AWS added to the protocol. But look at how the shared public key server URL is being assembled. This is exactly what initially seemed off. The same base URL is being accessed by all the applications in the region, and the only parameter that changes is the key ID, which could be supplied by the user. Now you can see why every application can access any other application's public keys. Remember the documentation that we read in the beginning? Like you saw the URL assembly line? This is the full code example from the AWS documentation, and you clearly don't see anything about the signer validation. And this created a situation where an attacker could pretend to be a user and ask the application to use keys that doesn't belong to it. Worse than that, he could ask it to use a key that belongs to him. Later, we even found an issuer forgery vulnerability that allowed us to basically force the ALB to sign our own controlled issuer, and then we completed the full authentication bypass. OK, so after we found this vulnerability, of course, we did the responsible thing and kept it all to ourselves. No, I'm kidding, of course. We reported a vulnerability to AWS in April 2024. And AWS started to investigate the issue. And within a month from the first contact, they made the first documentation change. So right now, they're asking the customers they added a corrected code example with a signer validation. They asked the customers to configure a specific ARN of the ALB instance and then validate it later in the code. And also, of course, a textual documentation that instructs the users how to do it. But they did this change without telling anyone not even to us. So, sounds great, right? Problem solved? No, of course not, because the customers now need to validate the signer in their code, right? So after continued discussions with AWS, they did another documentation change that instructs the customers to configure, to limit basically the traffic and configure the application target to only receive traffic from the ALB to close and mitigate this issue. And this is much more manageable than patching all the codes of all the applications. But they didn't notify their customers. So how the customers can take action even if they don't even know about it? Having understood the urgency of this matter, we started to contact potentially vulnerable customers, and we learned from them about how hard it is to patch the code across all the applications and instances, and how more easy it is to patch it in a more centric way using cloud configurations. And armed with these insights, we approached AWS again and suggested to make an proactive notification about this, and AWS followed along and did it. So the first one is a push notification to the vulnerable customers, telling them that they have a vulnerable ALB, and from now on, if you configure your ALB in a vulnerable way, you also have in the health dashboard, they present the issue in the health dashboard. Okay, but then we thought to ourselves, were there maybe more cases like ALBeast? And by this, I don't actually mean an entirely new vulnerability, but a vulnerability that was patched during documentation change. And why we think that? Because we already saw it. Meet the Verified Access Service. The Verified Access Service is a zero-trust service offered by AWS to the customers, and because it shared the same architecture of authentication as the ALB, it also shared the same vulnerability. And it was also updated using the AWS implemented another documentation change in this service that you should validate the signer field here too. So unfortunately, we think that vulnerabilities like ALBeast are likely to reoccur, and we thought to ourselves, who in the organization is able to monitor all these subtle changes in the AWS documentation? It's a very hard task to do. And to help them to do so, we created the AWS Security Changes Project. The purpose of this project is to monitor and analyze all AWS documentation changes and present both security-related and non-security-related changes to the customers. And if it is a security-related issue, we also analyze the impact from this issue and present it with a short summary on the issue. I'm inviting you to visit the project using the QR code and look for services that you are interested in. It also are going to be in the end of the talk. So how the project works. The first stage is to crawl all AWS documentation every once in a while. Once we do it and we have the current version, we take this and compare it to the previous version that was pulled. We basically normalize it into MD format, so little changes won't be considered as new changes. And then after we have this MD format, we use git diff to compare the current version to the previous version that was pulled. Later, we take all those changes and send them to a reasoning LLM to understand if there might be security impact out of it and if it's even security related or not. And then we store all the changes, the enriched changes in the DB and present it in a searchable way using the AWS Security Changes website. Cool. So after we spoke about the project a little bit, let's see a real issue that we found using the project. And we found 7 issues using the project, and this is one of them. OK, so we were interested back then in the ALB service because we found the vulnerability in the ALB service. So we monitored the documentation changes. And then we saw this issue. which allegedly has a clear clarification about including the account ID in an S3 bucket resource name in one of the IAM policy. Looking at it carefully, we saw that this is related to the ELB logging mechanism. But why did they do this change right now? We also see this new warning box in the documentation that instructs the customers to include the account ID in the S3 bucket resource name and to not include wildcards. We click on the documentation link in the AWS Security Changes project, and then we get to the actual page in the AWS documentation that was patched, and we see this IAM policy. So AWS instructs the customers to allow the log delivery service to write logs on their bucket. The log delivery service is shared for all the tenants in AWS. So look at the previous version. Based on this, if one account configured their ELB to write logs on completely other accounts' S3 bucket, it would work, because any account allow a full write on their bucket in the previous version to the log delivery service. And the log delivery service is the service that writes the logs for any account in AWS. So this can cause, of course, wallet draining and unrestricted resource consumption. And it's a very common vulnerability in cloud environments, and it's called the confused deputy. And we found 4 more confused deputy issues using the AWS security changes. It's very hard because it's very easy, sorry, because you have hooks to search by, like permission and principal and stuff in the IAM policy, like keywords from the IAM policy. And I invite you to do the same and help us all as community. This is completely free and community resource. I invite you to use it. And thank you very much.
Questions? We have time for a few. You can ask about the fact that the Python string concatenation didn't use the string formatter if you were triggered like me. Anyone? Questions? PEP8 is important. One here.
Thanks for the talk and also for the project itself. I also used it and looked into that. My question is, I sadly forgot the project which checks the changes of AWS managed policies and so on. Do you have also a look into that, because that's sometimes mentioned in the documentation? Or is that also out of scope and you say, okay, please look at that project for changes in the managed policies itself?
So you say there is another project that are monitoring managed. Can you repeat?
Yeah, there's another project which manage and looks at the changes of the AWS managed policies itself, not the documentation, but the policies.
Oh, no, we haven't looked at it because we saw that even AWS even have an RSS feed. So we saw that there are changes that does not appear on the RSS feed. So we said, okay, we want the ground truth. We want what people actually see. We don't want to rely on other projects to do it. And it was a vibe coding project. It was very easy to do. So yeah, that's basically it.
All right, well, give him another round of applause.